And we are back, my friends. Welcome back to the Open Source Zone at We Are Developers Congress live with GitHub. Thank you for joining me. Sorry for the stop and start, but I promise I'm making it worth it. I'm stopping by every single one of the open source projects that are being represented here at the Open Source Forum. And now we're getting into some nitty gritty. All of you Kubernetes people out there are going to appreciate this project. I am joined by Bill. Welcome, Bill. Thank you for being here. And thank you for agreeing to talk to me. I'm not giving them a lot of choice, really. I just come and sit. And then they're like, okay, please. What do you need, lady? But we're here to talk about Cilium, which is one of the projects that's being represented here at the Open Source Zone. So if you don't mind, just tell us a little bit about yourself and what your role is within this project.
Sure. So I'm Bill Mulligan. I work at Cilium, which is a part of Cisco. And they pay me to work full-time on Cilium and on eBPF, which we'll dive into a little bit more later. I'm a maintainer of both the Cilium project, which is a graduated project in the Cloud Native Computing Foundation, and a maintainer of eBPF.io, which is like the community resource for the eBPF community.
Amazing. So you're living the dream of most people that tune into this show on Fridays, and that is you get paid to do open source.
Yeah, it's pretty awesome. It's cool to be able to work on open source full-time.
Beautiful. Okay, well, so I am sharing Bill's LinkedIn if you want to connect with Bill. I've seen that you've done a couple of streams with Microsoft and you're putting out resources. I think give Bill a follow. But we're here to talk about Cilium. And for folks who don't know what eBPF is first, maybe you can give us like a super high-level holistic view. What problem was Cilium trying to fix in the space, and then why eBPF? Take it away, Bill.
Sure. So we'll start at the very bottom. So eBPF is a Linux kernel technology. And what it allows you to do is to essentially modify and program the Linux kernel. So a lot of people like to make the comparison. What eBPF is to the kernel, JavaScript is. So suddenly you can change and add functionality on the fly. So rather than having just the existing functionality as it shipped to you, you can add new programs, add new functionality, change how things are working. But it does it in a safe way and a performance way, which is obviously very critical for something as important as the kernel to computing. So if you want to learn more, go to eBPF.io. There's a lot of great resources there. Like what is eBPF? We'll walk you through kind of how the technology works, providing you both a safe and performant way to modify the Linux kernel. There's a project landscape, and also probably one of my favorite projects that I've worked on is there's also an eBPF documentary there, and you'll find the link at the top.
I love this. Are you in this documentary? Like, I have to wait. Don't tell us. We're gonna watch it and see if we recognize them.
Well, this is the funny thing. I did all the orchestration behind the scenes.
I love it.
I was so busy putting it together, I didn't even make the B-roll.
Oh my gosh.
So at the end of the day, there's not a single mention of me anywhere in the film. And then, you finally see the final product, you get it out, and you're like, wait.
You're like, I did a lot for this.
Yeah, so.
Listen, you're the unsung hero of the eBPF documentary. That's so funny. Because I have a friend in the Angular community. It was kind of similar experience where I was like, I saw you for like 1.5 minutes. I thought you would have been all over this because this was you. But that's awesome. That's epic. All right, so tell us, this documentary does a really good job of explaining what eBPF does. And then how does Cilium fit into all of this?
Yeah, so eBPF has been around for about a decade now. But, no one's really running the latest kernel in production. And so it took a while for enough people to be rolling out into production, like kernels that supported eBPF and eBPF that could do interesting things. And so Cilium was built from the ground up on eBPF, realizing like, okay, this is a new way of thinking about how we can do infrastructure is when we can reprogram the kernel on the fly. And so what Cilium did is take that to networking and saying, okay, this is also about, like 8-10 years ago. So this whole new cloud native wave is coming, and it's going to change how we can think about infrastructure. We have a lot of dynamic workloads. We have a lot of ephemeral workloads. IPs are changing all the time. We can't kind of stick to static things like we used to.
Yeah.
And if we need to kind of redesign how we're doing infrastructure, how are we going to do that? And Cilium said, we're going to do that with eBPF. And so what Cilium does is it brings kind of networking, observability, and security into the cloud-native era, leveraging eBPF.
Oh, that's amazing. Okay, so how old is the Cilium project itself?
Yeah, so Cilium is right now about 9 years old. It's open source from the first commit way back in like December 2015. And how it originally began back in 2015 was IPv6 only. Like some real technologist diehards. We've added IPv4 support now. So,
okay.
But it originally began as the CNI. So in Kubernetes, you have all these pods running around, and it's orchestrating that, but it actually doesn't provide any of the networking, right? And so in distributed computing, it's only distributed computing working together if you can communicate and talk and network between all of them. So Cilium provides the networking between containers.
Okay.
That was like the original thinking. Kubernetes clusters, how can pod A talk to pod B?
Okay.
And there's lots of CNIs that you can choose from, but I think the reason why Cilium has really become the de facto standard for Kubernetes networking is not just because it provides this pod-to-pod connectivity, but kind of all the features that it layers on top of that too. And so the main ones that like people like really love is like one is like a lot of people aren't running a single Kubernetes clusters; they're running multiple Kubernetes clusters.
Mm-hmm.
How can you mesh them together in a way that this service A, cluster A can talk in cluster B, right? And being able to do that seamlessly and transparently to the application. Cilium provides a lot of benefits around like scalability and performance. So it replaces the kube proxy component of Kubernetes, and that really helps the scalability of Kubernetes clusters. And so we have we have to throw it in here like AI customers or users of Cilium.
Makes sense because there are 50,000 things that are run at the same time. So yeah.
Exactly. So they're using Cilium to run 65,000 node clusters. Yeah. So when you have that many nodes, obviously you need very high scale networking and needs to be very performant, and Cilium helps to do that because of the performance benefits that eBPF brings. Right? And then there's lots of other features and use cases. How do you get traffic from the world into your cluster? Mm-hmm. How do you load balance it across the clusters and services? Traffic from the cluster back out to wherever it came from. When something goes wrong in our network, how do we debug that? How do we look at the network flow logs and look at like this packet was flowing to the network and then it got dropped by this network policy, this rule, something else is misconfigured in our network. Cilium provides that through its component called Hubble. And the Hubble UI is a service map of all the different interactions that are happening in your cluster. So here, this service is talking to this other service. I think my favorite quote about this is like, Hubble took what used to take 2 engineers 2 days to figure out to 1 engineer in a few minutes. And that's the big difference. It's like, that's the thing that I can justify to my CEO about why we switched to Cilium.
That's amazing. Okay. And then security, which is so important.
Yeah.
Tell us a bit about that.
Security is becoming a really big part of everything that we're doing today. So one is, all this data is flowing over the network. Mm-hmm. How do we secure it in transit? So Cilium provides transparent encryption to all your network flows. And then the other part is network policy. How can we ensure, only the services, like if you're running, for example, a multi-tenant Kubernetes cluster, like the tenants are isolated from each other. How can we ensure if an attacker comes out, they can't egress traffic out? So, example, one of our users is Bloomberg, and they have a lot of critical financial data. How can we make sure that data stays on our platform and it can't be exfiltrated by an attacker or somebody who just made a mistake,
right?
And so that's super important too, is being able to do network policy in a good way. And the last part is...
Well, part of course, because interesting.
Exactly.
CNF.
And then this last part is runtime security. And this is done by a sub-project under Cilium called Tetragon. Mm-hmm. And this is the cool thing about eBPF is that it can see everything that's happening in the kernel. And based on these hook points, you can run specific programs. So you can say like, hey, is anybody trying to access the passwords file?
Okay.
And you can
be very specific. you're looking for. Very cool.
And that's really the benefit. I think a lot of people see like observability and security adding a lot of overhead to what they're doing,
Yes.
right? And we're all trying to like reduce our cost footprint, our carbon footprint, being more efficient in what we're doing. And that's one of the big benefits about eBPF is it's able to be very specific. So rather than saying capture all the logs from everything that's happening, be like for security, you're like, I don't actually care if an application is running normally. That's great. I shouldn't interact with that at all. I just want to know if an attacker is trying to access the password file, and you can monitor just that. And the only time that program will run is if somebody's making that syscall.
Oh, so it's like a reactive observability kind of thing. Oh, that's a really cost-efficient and resource-efficient way to work. Very interesting. I don't live in this Kubernetes world, but this is fascinating to me. So this is an adjacent project, and it focuses primarily on that, on security. Right. Very cool. So tell us a little bit about the GitHub repo. Which was the primary repo for Cilium? This is it, folks. Go ahead and drop your stars right now, please. Let's see the star count grow. And what kind of contributions are here? How can the community get involved?
Yeah, definitely. So the repo is just like Cilium/Cilium. Project on GitHub, of course. It's got, I think, almost 1,000 contributors now.
Wow.
Which is pretty cool. It's actually the third fastest moving in the whole CNCF ecosystem. So a lot of things happen.
Go, and it's 88% Go?
Yeah. So all the user space agent is written in Go, and then the eBPF programs are written in C.
Okay.
So does that make sense? And like a GitHub project, you got a contributing guide. It'll direct you to the different parts to get contributing. Also, if you join the Cilium Slack, then if you go to the Cilium website, there's just the join Slack up here.
Okay.
It'll send you a message, and one of the things would be like reach out to me if you have any questions. So
reach out to me.
Join the Slack. I'm happy to answer any questions you have about contributing. We're always looking to have more new people join the project. In fact, right now, Linux has the LFX mentor. So it's to help encourage new people to get into open source. And so right now, they're paying for a mentee to work on the Cilium project.
That's awesome.
Yeah. And so each kind of time they do the program, I usually try to mentor someone to help them get their start in open source too.
Oh, I love that. Okay. So right now, I'm sure you have plenty of open issues. There might be some there that might be interesting to all of you to look, but definitely recommend to join the Slack and ping Bill, not today because they're busy here.
Yeah.
But very, very cool. Okay. And so you say AI earlier, so I have to ask you. Now I have to ask you. So what's happening as far as AI? Because I can think of a million. Like we just incorporated like models into GitHub Actions pipelines, and there's a lot of applications that are actually useful. What's going on? What's next for Cilium in this new era, like ChatGPT loves to say, the new era of computing?
Yeah. So I would say one thing is, AI is like a gold rush right now, and I would say eBPF and Cilium are like the shovels and pickaxes. It's the thing that's enabling all of the AI infrastructure because it's more performant, more efficient, more scalable. So it's really enabling all of that. And then the other thing is like eBPF. It's like this kind of treasure trove of data, but data is an insight. And so I think eBPF is really great at surfacing the data. It's taking these kernel level insights, but a lot of people don't program in the kernel, don't understand exactly what the kernel is. So being able to go from data to insight, I think is like where we see AI coming into what we're doing with Cilium and eBPF.
Well, you heard it here first. Awesome. Bill, thank you so much for taking the time to share Cilium with us. I'm excited for everyone to listen. And if your Kubernetes curious, Kubernetes adjacent, and this is going to power the infrastructure for all the AI, all your AI needs forever and ever. So it's a good project to get into. Thank you so much for being here with us today.
Yeah, thanks for having me.
Oh, and also, we're going to have Bill come over to a full version of Open Source Friday where we'll dig more into the technical aspects of the project and then hopefully see a couple of demos, yeah?
Yeah, that'd be great.
It's like I didn't say yes, but I guess now I have to. Enjoy the rest of the conference and thanks for taking the time to talk to me.
Yeah, thanks for having me.
All right, friends, I'll see you back in a bit.